Okay, dear students, let's see what is there in this question. Two loudspeakers A and B are initially equidistant from a microphone M. The frequency and the intensity emitted by A and B are the same. A and B emit sound in phase. So the initial phase difference is given to be zero, and they are equidistant. They have the same frequency, so both of these sources are coherent. It means this is the perfect condition for the interference to take place. Definitely, they are referring to interference here. A is fixed in the position, but B would be movable. So B is moved slowly away from M along the line MP. The graph shows the variation with distance traveled by B of the received intensity at M. Okay, so as the B is moving away, so this is what is the intensity that is recorded at the point M, which will be dependent on the path difference. So the distance traveled by B is actually equal to path difference. I would be explaining you with the help of the diagram, no problem. So this is the diagram here. Okay, explain why the received intensity varies between maximum and the minimum value. So simple. For this question, we have a simple reason. We will say that both of the sounds, both of the speakers, they are emitting sounds at the same frequency, and so when they are going to overlap and they have a constant phase difference, so these kind of sources are called coherent sources. So when they meet at the same point, superposition of the waves will take place. Such a kind of superposition is known as interference, and in interference, obviously, a pattern is created of maxima and minima. So as the B varies in the distance. Okay, let me first show you what is happening here. Now you see, let us say this distance is L, and so this distance is also L between B and M initially. So what is the path difference here? So path difference is initially zero. When this B has started moving into the backward direction, let us say it has reached P, which is actually equal to L again. I'm just keeping this as a condition here. Let us say BP is equal to L. It is not given in question. I'm just taking it as an example. Now I'm talking about MP. Let us say the speaker is at P and one speaker is at A. What is the path difference now? The path difference now will be 2L minus L. So which is equal to L. Technically, it is BP. So I am clear at this point that the path difference will be BP. So the path difference between the two sources is equal to this distance, which the distance which is traveled by the speaker. Now, for the constructive interference, delta x is given by n lambda, and for the destructive interference, delta x is also having a value. I would be explaining you this formula. Please don't get confused because this formula is not given in the data booklet. It is completely different from that. So don't get confused. I will explain you in this. So delta x is equal to this. So my only question is, in this case, we are not varying n and we are not varying lambda. What are we varying? Delta x. We are varying the path difference. Obviously, with the help of path difference, you are creating the variation, and you see if the constructive interference is happening or not. There is a possibility that now, after this much of the path difference, destructive interference will take place. That is why there is this kind of a pattern. Need not to explain too much. Yes, it is 3 mark, so you can explain a bit, but keep it a generalized answer that interference is taking place and so things. I will show you the answer now. Let's see. Uh, yes, the movement of B means that the path difference is different between BM and AM. Movement of B creates different path difference. Interference is there, superposition of waves, maximum when wave arrive in phase, and minimum when they are out of phase. So basically, they are just trying to describe. They created 3 different points to explain the same thing. So this is how you can write it. Nothing to explain there, and we have done it. Now let us move to the next question. State and explain the wavelength of the sound measured at M. So we are now concerned with the position M. We are not talking about the original wavelength which was emitted by the speakers. We are now concerned with the wavelength which is received at M. Okay, let's see now. So the wavelength which is received at M, and the only graph given is this, from where you have to take up the data. So we can say that when the path difference was 0, Like I'm referring to the constructive interference. So path difference will be equal to n lambda. And initially the path difference is taken to be 0. So that was kind of central maxima. So this is the point which was referring to central maxima, isn't it? Now after some distance, it has gone to point P, and it another loud sound is heard here, like because the superposition is taking place and the constructive interference is there. So definitely we are referring to this, and a maxima is heard at the point M. It means that this much is the path difference. This is like the distance traveled by B, so I can call it delta x. So this is the delta x, the path difference that is traveled, and after which another maxima is heard. So it means that we are only talking about the constructive interference. First of all, destructive interference is overlooked clearly. So once it is 0, and for the second case, the path difference will be equal to lambda, and n will become equal to 1. So that will be equal to lambda. It means that the path difference, that we can read it from the graph, that will be equal to the wavelength. I want to repeat this point. Please be careful. We are only and only concerned with the constructive interference and lambda. So first constructive interference will be occurring at this is equal to 0. Second will be occurring at lambda, which is called known as like kind of first maxima. This is central maxima. Now, if we are moving even further distance, that will become second maxima. It means that first maxima is occurring at this place. So delta x is the path difference that we have measured. That should be equal to the wavelength. So giving you this much of the information, we can now find the wavelength here. So finding this wavelength is not easy because the values are not given. So this is really bad, but we know that it will be more than 25. So it could be 26, it could be 27. If we refer to this point, this clearly seems to be 13 here, isn't it? Yeah, this seems to be 13, and you can use your ruler in the examination to see what kind of value would you be getting. So this will be 13, and this can be taken as 26. So 26, and the unit is centimeter. So 26 centimeter is the path difference when the second loud sound is heard, or the second interference, constructive interference is taking place, which means that this should be equal to wavelength. So your answer for this will be 26 centimeters, and let's see what is the answer. Yes, the wavelength is given as 26 centimeter. Okay, so let us move to the next question now. State and explain the wavelength. Yeah, we have done this. B is placed at the first minimum. Okay, now we are talking about the minimas. So the destructive interference, and now I would be explaining you what I was telling you earlier, that this formula is different. Please don't get confused. I will explain you that point now. B is placed at the first minimum. The frequency is then changed until the received intensity is again at a maximum. B is now placed at first minima. So we will find the path difference from this, and then the frequency is changed so much so that a maxima is heard now. Show that the lowest frequency at which the intensity maximum will occur is about 3 kilohertz. The speed of sound is given as 340. Frequency we want to find. Formula is velocity is equal to f lambda. Frequency we want to find, velocity is given. It means we must concentrate at wavelength. Anyways, let's see. Frequency is then changed to until received intensity is again at a maximum. Show that the lowest frequency at which the intensity maximum occurs about this. Okay, let's see. Yeah. So according to them, the first minima, first of all, let us read the graph. So that is occurring at 13 centimeter. Okay. So it means that, let us try to understand the question first of all. The question is saying that destructive interference was happening. So that will happen at delta x is equal to 13 centimeter. That is evident from the graph. So by the way, the formula that I was using, n minus half, so that we are not using. So I will not be wasting time on that now. After it, once we complete the question, I will create some little part there. You can skip that part if you know it, otherwise you can watch it. So delta x is equal to 13 centimeter, and now destructive interference is taking place. Okay, for the constructive interference to happen, we know that delta x should be equal to n lambda. It means if you are having a a different kind of wavelength, you can have a maxima even then. Like if I say that no, instead of 26 centimeters, we have 13 centimeter of delta x, I will say choose another kind of wavelength for which this variation will be there. Like in that case, I was telling you that the wavelength was coming out to be 26 centimeter and destructive interference will be there if delta x is 13. But there is a possibility that you use a wavelength of 13 centimeter instead of 26 centimeter. So when the path difference is 13 centimeter, you would be finding a constructive interference rather than the destructive interference, because this wavelength is different and that wavelength is different. I hope I am clear now. So we will see this and we will say that okay, fine, the maxima can be created if the wavelength is 13 centimeter. It means our new wavelength should be 13 centimeter. It means that the frequency is increased. Earlier it was 26 centimeter. So now the wavelength is 13 centimeter. Having learned this much, we move to the given data here. Yeah. And here I told you that we would be using the formula V is equal to F lambda. So the velocity is given as 340. Frequency we don't know because that is what we want to find. The wavelength has to be taken as 13 centimeter now. I hope you understand this question. Please watch the video again. Try to understand the concept that I have given. If there is any problem, please mention that in the comment section. From here, we find that the frequency should be given by this, and answer will be coming out to be approximately 3 kHz. Let us see. 340 divided by 0.13. And the answer is 2.615 kilohertz. Definitely, like it is about 3 kilohertz. So definitely they will not be giving you the correct answer there in the examination, but it is actually about 3 kilohertz. So this answer is absolutely correct. Let us see what they have done in the mark scheme. Yes, do you see this? They have just taken 13 centimeter. They have not explained anything. So they say that the 13 centimeter destructive interference is taking place. So that will be the minima. And that has to be converted into maxima. How that can be converted if the wavelength will be 13 centimeter for the new case. So in the new case, this is lambda dash that you are using 13 centimeter and thereby you get the answer 2.6 kilohertz. Okay, dear student, let us move to the next question now. Loudspeaker A is now switched off, so interference is over. We are only concerned with the loudspeaker B. Moves away from M at the speed of this. So speaker is moving away at the speed of 15 meter per second. This is the observer, you can say, and this is the source of the sound. The frequency emitted is given as 3 kHz. So we will not be assuming it to be 2.6 now, because this is like kind of qualitatively different question, and they have given it that it is emitting 3 kilohertz. We are not concerned about the answer that you were getting earlier. So this is emitting a sound which is going in this direction, and the frequency, original frequency, is 3 kilohertz. Determine the difference between the frequency detected at M and the frequency emitted by B. So this is the frequency actual which is emitted by B, but the frequency which is received by the observer, we have to find that. And this question is not from the interference, but this is from the Doppler's effect now. This is from the Doppler's effect now. So if this is Doppler's effect, let us see. Now, even here, I'm going to explain you a couple of things. They are very, very important. Please concentrate here. As per the Doppler effect is concerned, that topic is very confusing. There are so many formulas given in the book. There's so much confusion there. There's so many things given in the data booklet. Don't get confused. I'm going to give you one formula and one particular method that you have to use every time to get the correct answer. The only formula that you have to remember is this. This is the velocity of the sound minus velocity of observer divided by the velocity of sound minus the velocity of the source. Okay, so it's os kind of thing, os. So remember it that o is in the numerator, s is in the denominator, f dash is the apparent frequency, f is the real frequency that was emitted by the source, v is the speed of sound. Now, this is the formula that you have to remember. Don't be confused about whether it will be plus or whether it will minus. It will be minus. We would be assuming it to be minus on both the things. This is my method now. Okay, listen to this now. We are going to assume the direction in which the sound is going as positive. This is about the sign conventions now. Obviously, sound is traveling from the source to the observer. If the observer was on the back side, so the sound would be moving into the left hand side. But in this case, sound is going towards right hand side. So this direction is chosen to be positive. So this velocity will be taken as negative. And the observer is not moving. So if the observer was moving in this direction, the velocity will be taken positive. If it was moving in this direction, it would be chosen as negative. But in our case, this is not the case. The observer is not moving, so the velocity is zero. Now we are going to plug in our values. I will show you. The frequency is 3 kilohertz. So I'm not putting 1,000 there. I'm just keeping kilohertz, because if you substitute the value in kilohertz, your answer will be in the kilohertz only. So we don't care about kilohertz now. Okay. Velocity of sound is given earlier. It was chosen as 340, which is chosen as positive. Velocity of observer is 0. So 340 in the denominator minus. Velocity of the source is taken to be negative. So this is how we plug our value. This is our final equation. Use the calculator and find the value. So it is going to be 340 multiplied by 3 divided by 340 plus 15. Yeah, so I would be getting the answer 2.87. 2.87 kilohertz is the correct answer for this question. So, my dear students, do not get confused with the Doppler effect. There are so many formulas given in the book as well as in the booklet. Complete confusion, complete mess. Don't go to that thing. Just follow my method. You can call this method Varun's method. Okay, now another Varun's method for the destructive interference that I'm going to share, that is now. I think the question is over. Yes, the question is over. And now I'm going to tell you about the destructive interference. Please be careful. The students, those who have already seen a lot of videos and you know what I'm going to teach, and the students, those who are in my private classes, they know what I have taught. Fine, you people can now close the video and you can move to the next. But the other students, please be with me and listen to this. As per the interference is concerned, two kind of interference is there: constructive and destructive. In constructive interference, what I say, that the path difference should be equal to n lambda, and n can have a value of 0, 1, 2, 3. Simple. These are all natural numbers. All natural numbers are allowed when you talk about the constructive interference. And let me draw the pattern, a somewhat pattern for this. It looks somewhat like this. So the peak, this amplitude is not reducing in this. So I'm not considering diffraction. Okay, I'm just talking about the fringe pattern which is produced in the interference. So this is the central bright fringe. It is not first bright fringe. Central bright fringe. For the central bright fringe, the n is found to be equal to 0. This is the first bright fringe that I'm going to draw now. This is first bright fringe. This one is the second bright fringe. Similarly, this one is found to be third bright fringe. So if I talk about fifth bright fringe, you now know that n should be equal to 5. No confusion at all. There is no problem at all. But the problem comes when we are talking about the destructive interference. Now, as per the destructive interference is concerned, there are now two formulas. One is given in your books, it is given in your data booklet. Another is the formula that I am referring to. So you can learn the concept and you can use any formula as per your learning, as per your convenience. So in this case, delta x, like first of all, I'm going to teach you what is my method. So I say that n minus half into lambda. It can also be written as 2n minus 1 into lambda by 2. And in these kind of formulas, n value is starting with 1. 0 is not there, n cannot be equal to 0. Obviously, there is an obvious reason for this. Listen to this very carefully. Now, where is the destructive interference happening? This is the point where the destructive interference is occurring. Let me choose another color. Yeah, this one. This is the point where the destructive interference. This is the point which is second destructive fringe. This is the point which is the third dark fringe. I'm going to name them now. This is third dark fringe. This is the first dark fringe. This is the second dark fringe. For the third dark fringe, n is equal to 3. This is n is equal to, this is n is equal to 1. Easy, isn't it? The formula is there in front of you, n minus half. You substitute the value. Now, if I talk about the fifth dark fringe, one thing is clear that you would be using n is equal to 5 in this formula, just like constructive interference. Same is the pattern with the destructive interference. And there is no problem about the n. This first fringe is called the central bright fringe. Just a moment. Yeah, this is the central bright fringe. No confusion at all. No confusion at all. This is the first bright fringe for which n is equal to 1. This is the first dark fringe for which n is equal to 1. Now, this is my method which you can use very easily, and there is a very less chance that you would be committing some error. But you have to remember this. If you are good at remembrance, remember this method. This is the best method. Now I tell you what is your book doing and what is the data booklet showing and why it is erroneous. I would be using some other color now. Let me use green color now. Now see, the book is saying that the delta x is given by n plus half into lambda. N plus half into lambda. Okay, even this will become like 2n plus 1 into lambda by 2. Why is this formation and this formation important? These two formations are like odd multiple of lambda by 2. Many times you would have read this in your questions. Many times you would have read in the book. For the destructive interference, it is the odd multiple of lambda by 2. So 2n minus 1 is also odd number, 2n plus 1 is also odd number. That is the essence of this formula and this formula, nothing more. Now let me concentrate on n plus half. Now what is happening in this is that n will be having a value starting from 0. So here for first dark fringe, n is equal to 0. For second dark fringe, n is equal to 1. That is the problem. It means that in this case, for the fifth dark fringe, n used will be n is equal to 4. This is the discrepancy that I want to avoid. Do you see this? In the constructive interference, your data booklet is using this concept. And for destructive interference, your data booklet is using this concept. But that is not written in the book. That is not even given. Like there is no caution, there is no warning given in the data booklet that for constructive interference you have to use n is equal to 5 for the fifth bright fringe and you have to use n is equal to 4 for the fifth dark fringe. That is not given in the data booklet. That is why like the innocent students are making these mistakes. Although they know how to do this, they are very good at the interference, but just because this is not given in your data booklet, it's an incomplete formulation that is given there. That is why students are doing these kind of questions completely wrong. So this, be very careful. If you are using my formula, there is no problem. For the fifth dark fringe, you would be using n is equal to 5. But if you are using the data booklet, because many of my students, they report me, sir, I don't want to remember any formula. I will I will only use the formula given in the data booklet. There are students like that. So, anyways, be careful that n will be equal to 4 in that case. Okay. Okay, dear students. So this is Professor Varun. I hope you are clear about whatever I wanted to teach you in this video. This is a very important video. We have learned interference to a big details. We have learned Doppler effect to a big detail. So this is a very important video. All the best. Thanks for joining. Please share the video with all your friends. All the best.